All right. Good morning, good afternoon, good evening, everyone. And thank you for joining us today. This is Multi-Cloud Happenings, your March edition. And I can't believe that March is almost over. Easter is this weekend and everybody's on spring break. So I'm glad you joined us today because I think we have a really important topic. We're going to talk about the Oracle Database at Azure solution, and we're going to have a networking deep dive. So we're really excited. So let's get started. So I am Tammy Bednar, and I focus on our Exadata Database Services, our base database service, as well as multi-cloud as well. And then also joining me is Suzanne Holliday. Hey, Suzanne, how are you today?
Hey, Tammy, good, thanks. Good to be here.
Awesome. And then our special, and I'm so happy for Thomas to join us today. Hey, Thomas, how's it going?
Hi, Tammy. Hi, Suzanne. Thanks. Happy to be here.
That's great. And I know
Me
that
too.
networking is your favorite topic, right, Thomas?
Yes, next to the database.
Next to the database. Good answer.
Okay, so we have to say this safe harbor statement that anything me or Thomas or Suzanne says, you can't write it to a contract because we're product managers, and so, but anyway, that we have to say that. All right, so let's talk about multi-cloud. That's why you're here about multi-cloud. And the reason the reason that multi-cloud is very popular today is because we know that you want the best of both worlds. You want to be able to get the best database service and the best application and put them together. And this gives you the choice of what application, what data source you want to run, and also where you want to run it. So this is why multi-cloud has become very popular. I know back a few years ago, it was, I'm only going to use one database cloud service. But then last year at Cloud World, then I heard customers that are running two, three, and even four different cloud services that gives them the ability to choose which application is best for their business and which data source is best for the service. And of course, being from Oracle, I won't lie, I'll be honest. Of course, we think the Oracle database is the best service to run with your applications. So there's a lot of different ways to implement multi-cloud, but what we're here today to talk about specifically is the Oracle Database at Azure solution. And this is giving you the ability to reduce the latency between your data source and your application source because we are co-locating or expanding, first of all, I should say expanding our partnership with Microsoft to co-locate our OCI database services in the same region as your Oracle applications. So this is really exciting to see this. And this gives you that choice of being able to run the best of Oracle and Microsoft all in one place. So not only are we co-locating your application and the database services together, we're also giving it a more Azure native capability to provision the database service from with the Oracle database service within OCI. So this slide kind of shows you the role or how you can get to that point to provision the Exadata database service and then connect it up with your Azure applications. So the first thing you're going to do is you're going to purchase in Azure Marketplace, and you're going to purchase the service, and then you'll be able to use your MAC commitments to apply for that Oracle database service as well. And then you're going to deploy, manage, and monitor through the Azure portal and APIs of the Oracle Exadata system. And then you'll be able to combine your choice of Azure services once the Exadata database service or the cloud database service is provisioned. So we are the first thing I'd say every question that we have all heard is, well, where are the regions that are going to be located that I'll be able to utilize? So this is more of a global footprint, up to date as of this month of March of 2024. And as you can see right now, we have 2 Oracle Database at Azure regions that are now active. One in the United States on the left-hand side, as you can see, in East US. And then also the second one that is now live is in EMEA, and it's Germany West Central. But you can see that we're going to be very busy working together with Microsoft to online all these other regions, these 13 total regions that are going to be coming online over the next, 7, 8 months. So this is really exciting. Hopefully you'll find this exciting and go, oh, right, that's the region that I want. I can't wait for it to come online. So I kind of hinted that the first Oracle Database Cloud service that is being provisioned using the Oracle Database at Azure solution is called the Exadata Database Service on dedicated infrastructure. Yeah, it's a mouthful. So basically, it's the Exadata Database Service in the public cloud. So if you're a customer of the Exadata itself on premises, or you're running a cloud customer, then you know this is the same look and feel and capabilities that the Oracle Exadata Database Service provides you to run your databases and your applications. It supports all the applications that you're running with your Exadata today. If you're new to Exadata Database Service, reach out to Suzanne and myself, and we'll be more than happy to talk with you one-on-one about what the Exadata Database Service is. But because this is a dedicated infrastructure, this means that all the resources that are provisioned are only for you. And Suzanne is going to go into more details to kind of show you what that infrastructure looks like as well. So with the Exadata Database Service, we run the Oracle Database 19c version, and you get all these options that come with a license included. And of course, being in the cloud, and this is why I really like the cloud, is the elasticity capability. You can grow vertically and horizontally with the resources that you require to run your databases and applications, and then only pay for those resources as well. So I know there's a lot of great information. So with that, I'm going to turn over to Suzanne, and she's going to talk to you about the Oracle Database at Azure architecture.
Thank you so much, Tammy. That was a really nice introduction. We have done a much deeper dive on the introduction to Oracle Database at Azure, Tammy, myself, as well as Thomas previously, so you can check that on one of our replays. But today we're just going to, again, go through the architecture at a high level just to set the scene, just to really describe those components. And then I'm going to talk about the networking, and then I'm going to hand over to Thomas, who's going to really talk about the Azure networking topologies in a lot of detail. So thank you so much, Tammy, for the Exadata Database Service introduction. And I think it's really important to talk about this particular piece in terms of the infrastructure, because at the end of the day, we are actually, as Tammy said, placing the actual hardware for Exadata into the Azure data center in the availability zone in that region. Now, obviously, multi-AZs are possible, and we'll go through that in a little bit, but obviously per AZ, we would have the Exadata infrastructure deployed there, which means that the data plane itself is in Azure. So this is why I'm going to talk about what exactly is this infrastructure that we talk about. So as Tammy's already mentioned, we've got the database service, and then we've got the storage servers as well. So we have on the Exadata Database Service, we have a minimum of 2 Exadata Database servers, and 3 Exadata storage servers always. And this is connected via a high, very, very high bandwidth connectivity throughput pipe called Rocky. Right, so it's a not rocky network fabric that connects the database service and the storage service together. And then we have like all sorts of goodness built in, whereby, we have ASM that you can also add to that storage layer to be provisioned in a high redundancy mode. And this is like we see on the slide, provides this triple mirroring across the data storage servers to give you that extra HA protection. So it's very important to talk about this because it's very, very high performance Exadata Database Service, which is paramount for many industries. And this is, like Tammy said, the first database service that we're rolling out. So just to describe a little bit about it and how it works, because we're going to be talking about this in relation to the networking components. We've got virtual machines that run on the Exadata database servers, right? And the VMs from each of the Exadata database servers form this cluster. So you're going to be hearing us talk about VM clusters, right? And just so you know, we've got database homes and all the usual stuff that we have with databases, and VMs can host one or more database homes. And obviously you can have database homes that host one or more databases as well, in this case, Rack and Exadata. So as Tammy's already said, the real advantage behind this is that it can be scaled vertically and horizontally, which enables you to have this supreme performance and capacity and have this pay-per-use. Now, we're going to be talking in the next section about client and backup networks. So I just want to just briefly let you know that this is what the application users and administrators use to connect to the database service. And this is why it's important, okay? So this is what we're going to be going through and explaining how that's deployed on the Azure side and the OCI side as well. Now, Exadata is a co-managed model, which means that we're going to be obviously, Oracle is going to be operating certain elements, and the customer is you yourself as well. So we own and manage the infrastructure, which means the database servers, the storage servers, the internal fabric. And this is like all down to Oracle Operations that does this. And we do this through the management network, which connects to the database and storage hardware as well. Now, customers, you can actually, you actually have a customer VM called DOMU, and that includes the database software, the grid infrastructure, the data, the schema, and the encryption keys, and so forth. And then the Exadata Database Service itself, as Tammy's already mentioned, has great attributes in terms of life-cycling tasks, such as provisioning, scaling, patching, backup recovery, and cloud automation, which really brings all this together. So with that, that's really to talk about the data plane and the fact that it resides in Azure. So if you go to the next slide, please, Tammy, let's take a look at the high-level architecture now. So as you can see on this slide, we're going to walk through the Azure region and the availability zones, and then I'm going to take you through what the child site means, as well as what you can see on the very far right, the availability domains in the OCI region. So in this architecture diagram, we've just, for simplicity's sake, chosen to depict a single AZ. And this is showing an Azure Kubernetes application connecting to the Exadata Database Service on dedicated infrastructure. We call it ExaDBD for short. And as Tammy's already explained and I've mentioned before, we're deploying the hardware and the Exadata X9M dedicated infrastructure into the Azure data center, and it's configured in that availability zone in the Azure region. And this is what you're actually seeing here when you're looking at that Azure region. It's that encapsulation of the Azure networking along with the OCI child site together. So this OCI child site is containing the Exadata infrastructure, the hardware racks, like I've said, are placed in the data center. And this enables us to achieve this, this really lowest latency possible connection for Azure applications to use the Oracle Database Service, in this case, ExaDBD. Now, with the network traffic, you can see on the very far right, we are using the control plane in OCI, and you have obviously a choice to use the OCI Vault encryption as well. And all the automatic backups used for Exadata Database Service go through this OCI managed network, which is represented by that pipe in the middle. So now I'm going to talk about how we actually set up this networking between the Azure side and the OCI side, so that we're actually enabled to deploy the Exadata service, Exadata Database Service in full in an Azure availability zone. Thank you, Tammy. Could you go to the next slide? Thank you. Now, the reason why we're starting with this is because we really need to, as I said, we spoke about these client subnets and the backup subnets. And it's important to really understand when you're actually planning your side arrangers and your subnets, exactly how many IP addresses you're going to be configuring, and that your IP addresses are calculated correctly to actually fall into the correct size of the subnet that you've specified, which is what that table in the right is showing. Now, it's depicted here in this table that we have we're talking about, we have this flexible infrastructure. So we don't talk in rack sizes anymore in sense of like, a quarter rack, half rack, full rack, because as Tammy's already said, we're actually deploying flexible architecture, flexible infrastructure now, and we can actually size up the database servers and the storage servers as needed. But what's important for you to understand is that per cluster, and this is very important to emphasize, this is per cluster calculations, that we have on a database node basis, we calculate 4 IP addresses per database node per cluster. And this is because we have a minimum of two floating IP addresses and 2 static IP addresses. Now, just to talk about those briefly, we're allocating 4 per database node. And when you go to look at these IP addresses in the OCI console, you will just see the static and the floating IP address, i.e. the static being the private and the floating, because we're assigning the other 2 for network bonding purposes, and we don't actually show those. I just mentioned that because we get a few questions on that sometimes. Now, in addition to those 4 IP addresses required per database node in the cluster, you also need to attribute and assign 3 scan IP addresses as well for the cluster. Now that's the Exadata database side of things, right? However, because this is Oracle Database at Azure, we've also got to allocate additional IP addresses. So if you look at the second column when we're talking about the client subnet, we are saying here that we're allocating in total 13 IP addresses, because we have to allocate 8 for the Oracle Database at Azure and 5 internally for we need to reserve 5 for the VNet in Azure. So while in OCI, we have this, we reserve 3 in OCI. In Azure, they reserve 5 in the VNet. In the actual we reserve 5 IP addresses in the subnet for Azure. So this is what this footnote means at the bottom. We've started that comment to say that we've got these 5 IP addresses assigned and this additional 8 IP addresses in the subnet, which makes 13. So in this particular example, we're just showing, if you've got one cluster with 2 nodes or a cluster with 4 nodes, to show you the respective calculations. So obviously here we've got in the 4 nodes, we've got 4 times 2 is 8, because we've got 4 nodes, 4 IP addresses per node. And then we need to add the 3 for the scan, which makes 11. And then we have to actually add the additional 13 as well. Okay. So just be mindful, though, when you're planning that you've got, the more additional database nodes you add, that's going to affect how many IP addresses you're going to be adding on. And that is very important when you're planning your side arranges as well. So another thing to note, now we've got more than one region as well. If you're setting up Exadata Database Service with the VM clusters and the VCNs in more than one region, you've got to make sure that the IP address space of the VCNs do not overlap and so forth. So this is important when you're implementing data guard and so forth. So next slide, please, Tammy. So I'm just going to talk about 2 things here. I'm just going to talk about the Azure side of the networking, and which is depicted on the far left in this high-level architecture diagram that I showed before. And then I'm going to explain about the OCI side and how they interact together. So let's just talk a little bit about the VNet and what goes on in there first. Thomas is going to dive deeper into the various Azure network topologies. So prior to creating the VM cluster, You can see that we've got two subnets listed here. We've got a client subnet, which in brackets says delegated, and then we have the application subnets. The application subnet is where we've deployed Azure Kubernetes Service, and the client subnet is delegated. Now, prior to provisioning the VM cluster, you need to create a delegated subnet in Azure. Okay, so this delegated client subnet is required so that in a VNet in order to deploy the Exadata VM cluster. So you're not able to deploy any applications in this subnet, which is why you see we've got the AKS installed in its own application subnet. And this is just Microsoft. This is a Microsoft thing. This is a subnet delegation is a way for Microsoft's ability to inject like a managed service. So like you could have a platform as a service directly into your virtual network. You can call it anything. We're calling it delegated subnet because we're delegating it for the Oracle database at Azure. Okay. And when you're doing that, you set that up in Azure first, and you create this delegated subnet and you specify the Oracle database attachments as well, which you can see in the documentation. Another thing to note that it is important is that we cannot assign a network security group. That can't be defined in the Azure delegated subnet. So we do, and we actually create that in the NSG in the OCI side instead. So just to elaborate on this, what we're saying is that we need a VNet with a subnet, the client subnet in Azure, and that client subnet needs to be created and delegated before we deploy the actual VM cluster. Now, we're not going to go through this today, the provisioning, but the provisioning happens on the Azure side in order to deploy the infrastructure and the VM cluster. Both of those are done in Azure, whereas the database is done in OCI. So before you go ahead, I'll say it one more time, and deploy your VM cluster, you need to have created this delegated subnet as well. And it's important to note that this is where we're doing it for the client subnet, but it's also important to note you see on the right side, on the OCI side, we have a backup subnet as well. And we need to provide this backup subnet side block during the VM cluster deployment. And this backup subnet will be deployed, as I've just said, in OCI and not in Azure. But we do need to make sure that we're not overlapping with the network stack there. Okay, so one thing as well that I want to talk to you about is this VNet on this diagram in the VNets as well. So we have several VNets that are created in the Azure VNet for connectivity to the database nodes, as I've just described, as well as the scan addresses per cluster. And that's why I started with that, so you can understand this is where they're being deployed, actually in the VNet itself, and they connect all the traffic routes through from the application through these VNets into the OCI child site, and where we've got the Exadata infrastructure installed. Okay, and let's go ahead and talk about the other side. So if you go to the next slide, please, Tammy. Thank you. We are now going to talk about the importance of the availability domain and like how they're kind of coexisting in a network sense. So on the right, if you're not familiar with Oracle Cloud Infrastructure, VCN is what we call an AZ, an availability zone in OCI. And this VCN that we're depicting here on the right, which houses this client subnet and the backup subnet, this is created at the time of the VM cluster creation, and it contains both the client and the subnet with the identical side ranges, which I'll explain in a second how we do that. So these IP addresses are assigned randomly within the client subnet in OCI. And once assigned to the private endpoints in the VCN, at that point, and this is all done via our automation as part of the Oracle Database Azure deployment, we then create and duplicate these private endpoints as VNICs in the client subnet in Azure, because we need to use the same IP addresses for these VNICs as the same private endpoints in the VCN on the right-hand side. So like I said, this is a VCN dedicated for the VM cluster for the Oracle Database at Azure. So it's not for customers to deploy here. Okay. So if you go to the next slide, please, Tammy. I just wanted to just show you before I hand over to Thomas, is that you can actually, in terms of those database IP addresses that we were talking about, you would go into OCI to see those. But the database nodes IP addresses, excuse me, but then the scan IP addresses you can actually see from the Azure portal when you actually go into the Oracle Database at Azure Service. And also you can see the DNS names in Azure for the scan as well. So that was just really to give you a background on the high level architecture, how we create the networking from the Azure and the OCI side. And now Thomas is really going to talk about the best practices deployment of your network topologies. Thank you, Thomas.
Thank you, Suzanne. Thank you. Yes. So thanks for the explanation on how this is architected. So we know how we are deploying the networking of the Exadata service into the Azure VNet, but then the step, how do I connect my applications? How do I connect my on-premise environment to this database? How do I connect another spoke VNet? So we created a few slides on the network topologies and what the best practices are. Next slide, please, Tammy. So the first topology that we have is actually the topology that Suzanne was also showing in the example of Azure Kubernetes. So here you can actually create your application subnet inside the same VNet where you have created your client delegated subnet for the VM cluster. It's important to have a separate subnet because that delegated subnet does not allow you to create any other resources. Therefore, a separate subnet is needed within the VNet. This this topology offers you the lowest latency because they're located within the same VNet. Of course, while you deploy your application, it's best to see that you deploy it within the same availability zone as where your Exadata has been created to improve the latency. But it also is the cheapest. It incurs least cost, let's say, because by doing this, you do not have any egress or ingress costs, which you do have for the next slide, where you can set up a similar setup on the Azure side, but using VNet peering. In this case, the VNet, the application is residing in a subnet in a peered VNet. It's a direct peer VNet on Azure. So you can use this peering. It will not add any latency. So the peering does not add any latency compared to the previous setup. However, it does add costs because Azure does charge for egress and ingress cost for VNet peering. Next slide, please. Of course, a lot of our customers already use a hub and spoke topology within within their Azure network environment. And the first hub and spoke topology that we can that we're showing here is a hub where the hub is actually a V1 hub, which you configure in your region. So the V1 hub serves as the central point of connectivity between, in this case, the application and the database spoke. Both of those are peered to the V1 hub. In this case, there's a firewall configured within the V1 hub. It doesn't have to be, but if you would like to inspect your traffic between the database and your application, you can add a firewall hub here. All the routing between the spokes is managed by the V1 hub. What is important to know is that compared to the previous two topologies where we have the application deployed within the same VNet or with direct peering, this will add some hops to your network connectivity. So for low latency deployments, one of the two previous topologies are recommended for your industry standard or company standard. If you want to use a hub, this is one of the possibilities of using a hub and spoke model. The next slide, please, which will also show a hub and spoke topology. But in this case, we are not using a V1 hub. In this case, we are using a central hub VNet for the connectivity. And within that central hub, we have a routing device or a firewall, which makes sure that the traffic can be routed between the database spoke and the application spoke in this case. However, the delegated subnet currently, Azure delegated subnet currently doesn't allow bidirectional traffic directly from the database, for instance, to the application host. And for that, you do need a local NVA. It's just a term, but it's the local NVA that we are calling it. That adds an additional routing device within the database VNet. In this case, the routing will happen from the Exadata to the local NVA, then passes through the hub to the database or to the application spoke. This extra hub also incurs, of course, a extra latency. So direct peering, if you have a latency sensitive application, direct peering is, of course, still the most recommended. Next slide, please. So next to the hub and spoke confined within the Azure region, you also can extend that hub and spoke towards your on-premise environment. So in this case, what we're showing here is a hub and spoke with the connectivity centralized in the hub network in Azure, without a firewall. So if you don't need to inspect traffic to on-premise and you don't need a firewall, as you can see, in this case, you also don't need that additional routing device in the database VNet. So bidirectional traffic and routing is done through transitivity of the gateway and also through the direct VNet peering between the hub and the spoke. Again, VNet peering incurs additional costs, of course. Next slide, please. Another option that you have to allow connectivity from on-premise is very similar. In this case, instead of VNet acting as a hub, we can also use the Azure V1 hub. In this case, we are putting a firewall in the V1 hub. And because all the routing is done by the V1 hub, also for the attached database VNet, there's no additional routing device needed in the database VNet. Next slide. And of course, this is the third possibility of connecting your on-premise devices or on-premise network to the Oracle database at Azure. In this case, we are using a hub VNet, and in this case, we do need a firewall. So you do need to inspect traffic coming from the on-premise network. So if you do need this firewall, again, the current technology available requires you to create a local VNet, local NVA in the database VNet. So an additional hop is needed to route traffic between on-premise and the Exadata Database Delegated Subnet by adding a routing device within your database VNet. Next slide. Then, of course, there's a lot of questions on so when we are available in more than 2 regions, which is the case, how do I connect to regions? So I already the customer or you or we already created a application in one Azure region, but we're deploying the database in another region. We want to connect those applications. So, of course, this is not for latency sensitive applications because the region spans well, they're far apart. But in some cases, there are requirements for our customers to connect an application in one region to another region in database in another region in Azure. In this case, what what is supported is to create a V1 hub in each region and then use peering to the V1 hub to those to the local V1 hub in your region, and then connect both V1 hubs to each other. So in Azure, there is also a possibility for non-delegated subnets or for non-affected delegated subnets to connect 2 VNets with global peering. Currently, this is not available. So currently, if you need to connect 2 of the 2 regions together, this is the supported method to do so. Next slide, please. So going a little bit away from how we are deploying the networking on the Azure side is, of course, you can also use the OCI VCN to connect an application. So if you already have some application running in OCI and you desire to use the same data plane and connect using the OCI networking, that is possible. So one of the possibilities that we have here is that you add an additional subnet to the VCN that we are creating for the service, and within that subnet, the application subnet, there you can deploy your application VM or your service within that subnet. This allows the traffic between the client subnet to connect to the Oracle Database at Azure database and your application subnet. Next slide, please. Another possibility, of course, is that if you would have already deployed your application on OCI in a VCN, in a different VCN, you could also use local peering between the VCN that is created for the service and the VCN where your application already exists. So currently, this is only possible after logging a service request to allow to adjust the routing to allow the local peering. But using that service request, you should be able to connect those 2 VCNs together. Next slide, please. And this is an overview on a few of the examples that we had previously. So you can mix it up, right? So you can either do a direct network peering, as we can see, application VNet B is now directly peered to the database 2 VNet. But you can also have that application A running within a separate subnet. So you can mix it up. You can connect both applications to the same database. And of course, if you would want to create a connection between application B and to the database VNet below, that's also possible to hub and spoke, but then you require a local NVA in that VNet. So what's important here is you can deploy any of these topologies. If you would desire to run the same Exadata infrastructure VM clusters within the same VNet, it is possible to do that within the same delegated subnet in Azure. So currently, it's not supported to have multiple client subnets, delegated subnets within the same VNet. But if you run the same, if you want to run two VM clusters within the same client VNet, in the same VNet, same client subnet, sorry, in the same VNet, running on the same AZ, of course, then that is possible. So you could reuse that client subnet for multiple cluster deployments. Next slide, please. Okay, DNS. So for the DNS resolution, customers have a couple of possibilities here. Either you can use the fully managed DNS private zone, meaning this is a private zone created by the service, and it will use a FQDN like oraclevcn.com. It's managed by Oracle, but it's automatic. So the DNS will get forwarded into your Azure VNet automatically, but you cannot change the FQDN of your cluster or of your deployment. Now, another option is that you can create a custom FQDN. So in this case, you do need to create first a private DNS zone on OCI, which allows you to create your fully qualified name there. And this will also get forwarded into your Azure VNet. But you do need to create that private zone first. And of course, there's the third option where the customer has a custom DNS server. It can be on premise. And that's the third possibility. You create your private zone on premise, and you manage those private zone also in OCI, which then get forwarded into the Azure VNet. Next slide, please. So a quick comparison between the let's call it automatic private zone or managed private zone on the left side is where we create the private DNS zone automatically. We attach a domain called oraclevcn.com to it, and we sync this zone into your Azure VNet automatically. On the left side, here you can see a custom DNS zone. So the customer needs to create that customer, or you have to create that custom DNS zone in OCI. So once that is created, while you deploy the cluster, you can select this private zone. And in this case, we will also make sure that the zone gets propagated or DNS gets forwarded into your Azure VNet. Next slide, please. So this is an example of the screen where you deploy your VM cluster, and here you can select whether to use a custom DNS or use the default DNS private zone that we create for this service. So during the creation of your VM cluster, you can choose whether you want to use a custom DNS zone or a default private DNS zone. Next slide, please. When we talk about measuring latency, right? So there is a number of tools that are available to measure the round trips for transaction or for your network. We got tools like iPerf and NetPerf, as well as SOCPerf, which allow you to test the latency at the TCP level. And this is actually the best way to measure the latency between your database host and your application host, for instance, because the traffic that we are using for the database is using the TCP protocol. Now, a lot of people are also using things like ping or traceroute, which uses the ICMP protocol, which is in general not a bad tool. However, on Azure, ICMP protocol is being deprioritized. This means that it doesn't reflect a very 100% latency. It doesn't reflect 100% what the latency exactly is. So that's why we do recommend to use tools like iPerf, NetPerf, and SOCPerf to test latency between your client and your database host. And another tool which can be used is what we call OCI ping. OCI ping is actually a tool that is going to measure transaction or database round trip. So in addition to the VNet or VM to VM connectivity, this will also do a connection to the database. So it passes through the database listener, etc. So it will give a full round trip ID of what your database connection will look like to the Oracle database at Azure or any other OCI managed database. Next slide, please. That concludes my portion of the presentation, and I will hand over back to Tammy and Suzanne.
Thank you so much. I really appreciate that, Thomas and Suzanne. Lots of great information on networking. There's a lot here. I think you can show that or see that this multi-cloud option really provides a lot of flexibility and also gives you the flexibility to choose where you want your data plane and where you want your application to be. And Thomas has shown a lot of great options on how all the connectivity can work together to provide you the best connectivity with your applications and database. And so with that, I think we'll turn it over. Yeah, we do have an external Slack channel. Just wanted to let you know that we do have a Slack channel, an external Slack channel. So join us on that. And then Suzanne, I think there was a question that you wanted to quickly answer as well.
Yeah, sure. Would you just mind going back to the slide that Thomas was talking about for VNet peering topology? It's slide 20.
Let's see if
And then we can talk to that architecture. And you can also comment as well, Thomas, if you like. Okay, so, yeah, that's the one. Yeah. So if we look at the question, Q&A, Abdallah is asking, will Microsoft charge egress traffic, even if it is on the same Azure region? So this is just very simplified Azure region topology here that we're showing on this one. And the answer to the question is no. However, there are VNet peering charges that are incurred in this particular type of architecture that Thomas took us through. Microsoft have a pricing on their website about it, where they explain that you can have VNet peering that links the two virtual networks, the VNets, in either the same region or different regions, and that enables you to route the traffic through the private IP addresses, which they say carries a nominal charge, and you can see the pricing listed there. It's important to note, though, in that topology that the inbound and the outbound traffic is charged at both ends of the peered network. But also, Tammy, if you please go back to the high-level architecture diagram that we showed at the very start when I began speaking.
Okay, 1 second.
Okay. I just want to talk about the end-to-end ingress and egress as well, because
this doesn't
is it not working?
Hold on.
You can stop sharing if you like and jump to slide 12.
There you go.
Yeah, Okay, so the question was specifically around the Azure region. This is depicted in blue on the left, but customers obviously ask us from end-to-end ingress and egress charges as well. These are still within the same region, but you can see we've got this OCI managed network in between, which means that any of the network traffic that's traversing from the Azure application through all the way to the availability domain is not incurring ingress or egress charges. There are charges that come into play, as Thomas has explained, when you're architecting differently and you're traversing the regions and, for example, you're using V1 Hub and so forth, right? Which it is part of the Azure pricing, and you can see that on their architecture. I don't know when I was explaining the availability to domain earlier, whether I said that equates to no, I don't know if I said if the VCN equates to an AZ. I hope not. A VCN equates to a VNet in OCI that equates to the VNet in Microsoft Azure. I'm not feeling very well today, so I could have said that by accident. So I just wanted to make it clear. Yeah, so I don't know if you've got any other questions on pricing. If that answers your question, let us know. We've got a little bit of time left if we've got other questions as
Right.
well on networking or other even Oracle Database Azure questions as well. If it's not specific to networking, we can
I
ask.
will post this recording as well as a PDF of this deck in the AskTom session. So, or, if you go to the landing page, you'll be able to find it there, hopefully by the end of today as well. Let me see. I think there's another question. Whoops.
I know,
Okay.
just saying
It's more
that's
clear.
clarity.
Okay. Fantastic. All right. Thank you so much.
I
All
don't know if
right.
you've got anything to add, Thomas, to that answer that I gave. If there's
That
anything
was
else.
perfect. No, that was all. Yep, that was all that needed to be said at that level. Thanks, Suzanne.
Okay. Well, first of all, I want to thank everybody. I think that's all the questions we have today. So thank you, Thomas and Suzanne, for all this great information on networking. And thank you for everybody for joining us today. So come back next month in April for another multi-cloud happenings. And if you have any suggestions on what you would like to hear, we would love to hear from you as well. With that, I think I'll sign us off for the day and this webcast, and have a great month, everybody. And we'll see you in April. Bye now. Thank you.
Thanks. Bye.